All right, today we're in section 4.7, scientific notation. We're going to learn today how to write really big numbers in a shortened format and really small numbers in a shortened format. That's all scientific notation is. It's taking really very large numbers and writing them in a shorter form. Okay. All right, let's see. Okay, so in the first example, it says the retina has 120 billion rods. Write this number in scientific notation. So here's my rule. I need to move my decimal to a place in the number that gives me a value greater than 1 but less than 10. It has to be in that range. So I have 120 billion right here, okay? And I move my decimal to, and it's always going to be, guys, the place right after the first non-zero number. Do you agree that 1 2/10 is in that range of greater than 1 but less than 10? Is it in that range? Yes. If I were to try to move my decimal, let's say here, after the 2, that would give me a 12. But that's bigger than 10, so that doesn't work. In order for a number to be correctly written in scientific notation, it has to be in that range. That's why it's always after the first non-zero number. So now I multiply it by a power of 10. Why? Because place values are written in powers of 10. So if I'm moving my decimal, all right, into a different part of the number, I'm going to count how many places I move the decimal. Where is the decimal understood to be in this original number? It's after the last zero, after the ones place. Okay, so it's after the ones place. All right, so I'm going 3, 6, 9, 10, 11 places. So that tells me what my exponent is going to be. It's now written in scientific notation. Okay, so the decimal value has to be greater than 1, less than 10. I figure out what my exponent of 10 is going to be by figuring out how many decimal places I moved to get to the new value. Now let's look at the opposite side of things. What if I'm dealing with a really small number? And here I've got 0.00012 meters is the approximate thickness of the human retina. So if I want to write this number in scientific notation, my rule is still the same, that I need to move my decimal to a value that gives me a number greater than 1 but less than 10. So where is my decimal going to go in the second one? After the first non-zero digit, after the 1. So again, I've got 1 2/10. But what's going to make this number different is since I had to move it in the opposite direction, I multiply it by 10 to the negative power of, and I count 1, 2, 3, 4, 5. I move 5 decimal places, 10 to the negative 5th power. All right, we're going to do several more examples, but this is the foundation for writing a number in scientific notation. I take really large numbers, I shorten it to a decimal form greater than 1 but less than 10. I multiply it by a power of 10, and I figure out my exponent by counting how many decimal places I moved it. Okay, so in continuing with example 1, I wanted to do several problems here so that we could really hammer in this concept here. Okay, so what we're doing is we're trying to come up with a decimal value in this number that gives me a number greater than 1 but less than 10. Come up with that number, multiply it by 10 to some power. I want you to try the first one. We're going to work through these first 3 together, and hopefully on each one you start understanding it a little bit better. Okay, so who thinks they know the decimal value? What's the decimal value going to be? L'Oreal? What is it? What's going to be my decimal?
4.5.
Yeah, 4.52. Very good. All of the non-zero numbers. What do I mean by non-zero number? Any number that's not 0. So if you don't have to include the zeros in your decimal number, but all of your numbers you've got to include it in your decimal as well. So 4.52, yes. sorry, let me do it this way. Times 10 to the what? Do you agree with her? 10 to the 6th? Yes, she is right. Right? So what is going to be my decimal value for this second number? Aliana. Very good. 1.423 times 10 to the what, class? To the 7th power. Why? Because that's how many decimal places I moved it to get to my new decimal value. 4.2 times 10 to the 9th power, because I went 3, 6, 9 to get to 4.2. All right, times 10 to the 9th power. Now, in the second set of numbers, now I'm going the other way because now I'm dealing with really, really small numbers. But my rule is still the same about the decimal value. I need to place my new decimal after the first non-zero number. So where does my decimal go? 5.23. Does everybody agree that value is greater than 1 and less than 10?
Yes.
Yes. So now I multiply it by a power of 10, and I need to count how many decimal places I moved to get to the new decimal, and how many did I move? To the negative 5th. Why is it negative? Because I moved my decimal in the other direction, in the opposite direction. I'm dealing with a very small number, 5.23 times 10 to the negative 5th power. I want you to do the last two. Okay, so what decimal value am I going to have on the second one? 3.21 times 10 to the what? Negative 4th power. Times 10 to the negative 4th power, because I moved my decimal to the right 4 places. What's going to be my decimal value for the last number? 4.2 times 10 to the negative 7th power. Who got those right? Who got them right? Very good. All right, so now let's go the other way. Now let's write these numbers from scientific notation to the expanded form, the standard form. Writing numbers in standard form. What's important here is that we look at the exponent. If the exponent is positive, I know that I'm making the number very big. I'm moving my decimal to the right, making the number big. If the exponent is negative, I know I'm moving my decimal to the left and making the number a very, very small number. Okay, so the exponent tells me everything I need to know. It tells me how to expand the number. So since I have an exponent of 7, and guys, hear me on this, 7 is not how many zeros I add. It's how many decimal places I expand the number by. 3.2, and I go 1, 2, 3, 4, 5, 6, 7, and I expand my number. Okay? And then I'm going to clean up my number, and I'm going to write it 32 million. Write 8.69 times 10 to the negative 5th power. So now, since it's negative, I'm now moving my decimal to the left 5 places. And then filling in my zeros. And yes, I do want you to have a 0 placeholder in the ones place. 1, 2, 3, 4, and then 8, 6, 9. All right. Now I want you to do the third one on your own. Write 1.473 times 10 to the 4th in standard form. All right, so which way am I moving my decimal, right or left? To the right, because I'm making the number bigger. My exponent is positive, 14,730. Did you get it right? Okay, so positive exponent, I'm making the number bigger. All right, so now we're going to do one more slide. We're just going to do a little bit more practice. You're going to have one question on your quiz in each of these different versions. So you're going to have 2 where you write it in scientific notation and 2 where you write it in standard form. One's positive, one's negative. All right, so I want you to go ahead and work through these problems. Write the first 3 on the left in standard form, and then the 3 on the right in standard form. Okay, so first 3, here we go. 9,430,000. Did you get it? Yes. Finish up the last 3 if you haven't. Okay, what about the second one? What now? What's it going to be? 43,120,000. What about the third one? 2,310,000,000. Did you get all three? Raise your hand. Did you get all three? Good. Awesome. Awesome. Y'all still finishing up the last three?
Yes. I'm still doing it.
Okay, just another minute. All right. Point. How many zeros did you have to add? 7. And then a 4 and a 3. What about the next one? How many zeros did you need?
6.
Not 6, but 5. And then a 1 and a 4 and a 5 and a 7. And then the last one, there's 4 zeros after the decimal, and then a 5 and an 8. A 5 and an 8. All right, so that's it for 4.7. Now, I am going to include in the recording a recap from the 4.6 lesson. Hopefully, this just gives you a more condensed and concise version of the lesson from yesterday. I'm going over, on the next couple slides, the 2 concepts that you are going to see on your quiz on Monday. All right, and it's all surrounded around writing your answer using only positive exponents. How do I change the sign of the exponent? Here's my rule. If I have a negative exponent, I can write that part of the term in the other side of the fraction, and it makes the exponent positive. So let's say I had the term 3x to the negative 4th. Well, which part of this term has the negative exponent? Tell me. X to the negative 4th. The 3 is not negative, so the 3 can stay on top, and I move x to the negative 4th into the denominator, which reverses the sign. Now I have followed the instructions, and now I've written my exponent with positive. So number 2, I want you to try number 2. So which part gets to stay in the numerator?
12x to the 3rd.
Very good. Over y to the 5th. There we go. Now, what if I had a term that was raised to the power of 0? Does anybody remember the rule? What is it? It's always 1, whether it's a variable or a number. It could be any variable, it could be any number. Raised to the power of 0, it always equals 1. So now I have 1 times b to the negative 4th. So which part of this term needs to move? Which part of the term? B to the negative 4th moves to the denominator, and now I've written my answer using a positive exponent. Well, what about number 4? Try to do that one. How do I write my answer using only a positive exponent? Yeah, very good. So here's what I do. Now 8 to the negative 3rd is in the denominator, so I move it to the numerator. When I move it to the opposite side of the fraction, it works both ways. It becomes a positive exponent, 8 to the 3rd power. I don't have to write it over 1 because that's understood. All right? Now, you've got to understand this, okay? Now, in the next section that you're going to see on your quiz, we're going to apply the quotient of powers property and the product of powers property. What is that? What do those properties say? They say that when I'm dividing numbers, powers with the same base, I can do what to the exponents? Not add them, subtract. When I'm dividing powers with the same base, I can subtract my exponents. But here's what's different. Here's what's different with this section as opposed to 4.5. Now, and I want you to show this step, guys, and here's why. By showing this step, now you can visually see what is 6 minus 9? Negative 3. And here's what your instructions are going to say. Write your answer using only positive exponents. So how could I write this answer? 1 over 4 to the 3rd power. You move it to the other side of the fraction. Okay? All right, so same goes with product of powers. Product of powers property says that I can multiply powers with the same base and add their exponents. Well, what happens if I have a negative? What's 5 to the 3rd plus negative 8? Negative what? Negative 5. But I can't leave my answer like that. What's going to be my answer? 1 over 5 to the 5th. Then you're going to have some problems that have numbers also. 21 over 3, 21x to the negative third divided by 3x to the fourth. The first thing you want to do is simplify the numbers. How can I simplify 21 over 3? What is simplified? What's 21 divided by 3? 7. Okay? So now, and guys, again, please show this step for your sake, okay? Because it will help you not make a silly mistake on your quiz. 5x to the negative third minus 4. What's it going to be?
Negative
7x to the negative 7th. But I've got to write my answer using only positive exponents. On your paper, write what your final answer would be. Jared, what'd you write?
I wrote x to the 7th power over 7.
No. Jonadab?
1x over 7 to the 7th.
No. Aliana? I only move the part of the term that has the negative exponent. 7 was positive, guys. I can leave it in the numerator. Okay? 7 was positive. I only need to move the term that had the negative exponent. All right, now, what if I had this? Simplify the numbers and subtract your exponents. 26 divided by 13. 2w to the negative fourth, hold on, minus negative 11. You're subtracting a negative. It's already a negative. What happens when you subtract a negative?
It's adding normal numbers.
It cancels to a positive. So, and guys, rewrite this. If you try to do this in your head, you stand a greater chance at making a mistake. Cancel out the double negative, make it a positive. What's negative 4 plus 7? Or plus 11. Ugh, I said the answer. Sorry. 2w to the 7th. You have some of these on that homework assignment that I gave you yesterday. That homework assignment should go by pretty quickly. All right? There's not a whole lot of work to show. Okay? Not a whole lot of work to show. If you understand that, that should be everything you need to know. And we are done with chapter 4.